Okay, this truly should be the last video. I know you're cheering. I'm sure it's been kind of agonizing to watch these. Not quite the same as being together in class, is it? Alright, we did a bunch of volumes in the last video, so now we're going to talk about surface area. Okay, the area of a surface. Now, how is that different from just regular area? Well, regular area, you're usually talking about a two-dimensional thing. You know, if I say what's the area of a square, it's length times width or side times side. But if I turn it into a three-dimensional cube, okay, we talked about volume in the last video. Well, now we're going to talk about the area of all these sides. I got a front and a back, a left and a right, and a top and a bottom. I've got 6 sides to that cube. Okay, so if I want to know the total area of all 6 sides, I need to do a little more figuring than just the simple area of a square or a rectangle. Okay, there's a couple terms here we should talk about. The first one's called lateral surface area, LSA for short. Okay, and I'm on page, by the way, 748. Lateral surface area is just talking about the sides. Okay, so that's referring to the sides of an object. So in other words, not the top and bottom. Okay, so on my little figure here, the lateral surface area would be just these 4 sides. Not the top and not the bottom. Okay, and there's kind of a, I guess we could call it a shortcut formula. You know, one way to find the surface area of these 4 sides here would be find the area of that side, right? And then find the area of that side, and then find the area of this back side over here, and then find the area of this back side over here. There's 4 different side areas, and add those 4 together. Okay, and that's essentially what we're doing, but there is kind of a shortcut way, if you will, to get there, and we can find that lateral surface area by taking the perimeter. Yes, perimeter and area, we can use one to help us find the other. To find the perimeter of the base of that box, and then times it by the height. Okay? Perimeter times the height. That's the short way. Okay, as opposed to finding 4 different sides and adding those 4 together. A shortcut way is find the perimeter of the base and multiply it by the height. So let's do that. So if we look at an example here, example 7. Okay, we want to find, we've got a box, basically like the box I drew there, but let me draw another one here. And we just want the lateral surface area, not the top and the bottom, just the 4 sides. What do we know here? 24 inches by 12 inches by 20 inches. Okay? Find the lateral surface area. Well, it's going to be the perimeter times the height. So what's the perimeter? Perimeter of the base. So all the way around this base side here, okay, the box on the ground here, which is of course is the same as the perimeter of the top also, okay? So my perimeter is going to be what? I've got 24 inches plus 12 inches and then plus 24 inches and plus 12 inches, right? We've learned shortcut ways to find the perimeter also. It's twice the length plus twice the width, or you can simply add the 4 sides together, right? So 24 plus 12, 24 plus 12, if we add those 4 sides together, what do we get? I think we could probably do it in our heads, but let's do it. 24 plus 12 plus 24 plus 12, what do we get there? 72. Unit is what? Inches, right? Okay, that's my perimeter. What's my height? 20 inches. So the lateral surface area is going to be 72 inches times 20 inches. So I'm going to take that 72 now and times 20, and I'm going to get 1440. Now what's the units? Inch times inch is going to give me a square inch. Okay, in mathematics we write it inch squared, kind of in the field, if you will. Lots of trades and things. I'll write. Oops, I put feet. Duh. Square inches like that. Okay, but in math class we usually write it as inch with the exponent of 2. Okay. All right. Good deal. So that's a quickie, easy way to find, again, the lateral surface area. If I wanted to find the surface area of the entire box, including the top and bottom, well, I need to add to that, right? I would need to add the area of the bottom and the area of the top. It's just a length times a width. It'd be really easy to do, but example 7 doesn't ask us to go quite that far, so we'll hold off on doing that. Okay? All right. How about a triangular prism in example 8? Okay, triangular prism has got a triangle shape, right? Let's see, how can I draw this? And we'll drop that down like that. Okay, triangular prism. Again, lateral surface area is just the perimeter times the height, okay? But if I want to find total surface area, it equals the lateral surface area plus something else, right? Plus the area of the top and the bottom. And we've been using this capital letter B to stand for the base of something. So plus twice the area of the base, okay? And that's area of the base, which is the same as the area of the top. Okay, so 2 of those. One for the bottom, one for the top. Okay. Alright, let's do it. So how do we do this? I got to give you some dimensions. That would help, right? I know my prism is 15 centimeters tall. And I know that each of these little sides of the triangle, I'm just going to label the one here. They're all the same. 3 centimeters each, all 3 of those sides. And then I'm also given my height of the triangle, which is the perpendicular distance from the base up to the peak. And that's 2.6 centimeters. Okay, so I have everything I need to know. What's the perimeter? Well, the perimeter of my triangle is just go around the triangle. 3 plus 3 plus 3 is going to be 9. Let me just write that down. The perimeter is 9 centimeters. Okay, so my total surface area equals my lateral surface area. That's perimeter times height, so 9 centimeters times 15 centimeters. Plus now twice the area of the base. Ooh, baby, how do you find the area of a triangle? Do we remember that? Better go over here and write that. Area of a triangle, now we got to be careful with our terms here, is 1/2 what we call little base times little height. That's just the triangle. The little base is the length of the side, and the height is the perpendicular distance from that side up to the apex. Okay, so it's going to be, we'll just write this down here on the side here. 1/2 little base is 3 centimeters, and height is 2.6 centimeters. Okay, that's the area of the triangle. Well, I've got to do that 2 times that. Okay, so I'm going to have 2 times 1/2 times 3 centimeters times 2.6 centimeters. Okay, and that's how I'm going to find the total area of this triangular prism. Okay, so let's do it. TSA, total surface area. Quiet! Total surface area is 9 times 15, 135 centimeters squared, plus the 2 and the 1/2 cancel each other out, right? 2 times 1/2 is 1. So it's just going to be 3 times 2.6, 7.8 square centimeters. So when I add 135 and 7.8, I have 142.8 square centimeters. Okay? Sorry about that little shouting at my kid there. I put a note on the door that says, quiet, recording in progress, do not knock, be quiet, and what do they do? Alright, sorry about that. Thankfully this is our last video, right? Okay, so TSA, total surface area, is that of the triangular prism. Good deal. Let's do example 9. This time I've got a cylinder. Oh yeah, baby. A can. Example 9 says, how many square centimeters of sheet metal are required to manufacture a can that has a radius of 4.5 centimeters and a height of 9 centimeters? Okay, I'm trying to figure out how much material I need to make this can. And I'm given radius now, so that's half of my diameter up there, right? 4.5 centimeters. Okay, again, did not draw this very well to scale, but oh well. And 9 centimeters high. Okay, so how much metal do I need, assuming no waste, no overlap, the example says? Just give me the surface area of this can, okay? Well, surface area of the entire can is going to be the lateral area and then the top and the bottom, just like before. Total surface area, lateral surface area, plus twice times what we call the area of the base, okay? That means the top and the bottom. Well, how do I find lateral surface area? I take the perimeter times the height, right? Perimeter times the height. Now, and then plus twice the base. Well, when we're talking about circles, we don't use the word perimeter, we use the word circumference, right? So it's the same thing. Distance around. So in this case, it's going to be pi times diameter, that's the distance around, times the height, plus 2 times the area of the base. How do you find the area of a circle, remember? It's pi times radius squared. So 2 times pi times radius squared. Now I've got a radius and a diameter in my formulas here. I'm only given the radius as far as information goes. So I either need to make a correction here and turn that into radius, or I can simply just very easily say, oh, okay, the diameter of my can is also 9 centimeters. It's 9 centimeters in diameter and 9 centimeters high. Again, I did not draw it very well, but the radius is 4.5. The diameter would be double that 4.5, so it's a 9. We have everything we need to know. Total surface area equals pi times diameter, which is 9 centimeters, times the height, which is 9 centimeters, plus 2 times pi times the radius squared, 4.5 centimeters squared. Okay? Again, now, a sophisticated calculator, we could plug this whole thing in and hit the enter button. Okay? Let's piecemeal it a little bit here. Let's take pi times 9 times 9. So we're going to say pi times 9 times 9 equals, oh, come on, 81 pi. 9 times 9 times pi. How about if I do that? I just ran into this problem with another example, and I'm sorry I didn't troubleshoot it, but it wasn't just a minute ago. It was not leaving it as pi, and now it is. What am I doing wrong? Anybody know? I know some of you are saying, it's so easy, dummy. How about 9 pi? No? Alright, I'm sorry about that. Let me just do the old switcheroo to another calculator. I didn't look into it. It's a no-brainer switch. I know it is, but I don't want to mess with it now. So I need to take pi. So now I got to find pi on a whole new calculator. There it is. Shift button gives me pi times 9 equals 254. We'll hold some decimal places, then we'll round at the end. 254.469, let's say. 254.469 square centimeters plus, what's the other one going to be? 2 times pi times 4.5 squared equals 127.2. How many decimals did I do? 3 decimals. 235 centimeters squared. Okay, now I need to add these two things together. plus 254.469 equals. How are we told to round this bad boy? We were not told, but they're rounding it to the nearest tenth, so we'll do that also. Total surface area equals, wait a minute, what do they do? I was looking at the wrong problem. Ooh, they round it to the nearest whole number. 381.704, if I go ahead and continue what I've done there with the rounding. But now let's go ahead and round it to the nearest whole number, so to the ones position. I'm rounding right there. It's either going to stay a 1 or become a 2, so my TSA is going to equal 382 square centimeters. Okay? Sweet. That's example 9. What about a sphere? Ball. We found the volume of a ball or the volume of a sphere. What about the total surface area? Now you can picture with a ball there is no top and no bottom. So when I find the total surface area, that's all there is to it. There's really no such thing as a lateral surface area because there's no top and no bottom to a sphere. So the total surface area is a very simple formula. 4 pi r squared. That's it. 4 pi r squared. Example 10 says, I've got a sphere, aha, a little trickery, with a diameter of 90 centimeters. Diameter equals 90 centimeters. Find the total surface area. Well, the formula says 4 pi r squared, right? So we would either need to make a correction and turn this into a formula involving diameter, which we could do, but it would be just as easy to say, all right, radius is half the diameter, right? So 90 divided by 2 is going to give me 45 centimeters for my radius. Let's just do that. Easy enough. Okay, so now we're practically done. TSA equals 4 times pi times 45 centimeters squared. So let's do that here. 4 times pi times 45 squared equals, and let me peek and see how we round this puppy off. We round it to the nearest whole number, so let's do the same. It's going to be 25,447, right? 25,447. What's the units? Square centimeters. Okay? There we go. Sweet. Alright, that is a sphere. There's really nothing more to it. Alright, finally let's do a cone. That'll be our last example. A cone, we all know what a cone is. It's got a circular bottom, but then it comes up to a peak, right? So we need to understand a couple things. Regarding the bottom, we still have radius, or we might be told, diameter all the way across. One or the other. Radius is half the diameter. There's a certain height associated with a cone, right? Which would be this distance here. Okay, but also with a cone, there's something called a slant height, and that's going to be the length of the side here. Okay, the slant height. This is on page 750, by the way. Okay, we need to know the slant height now in order to calculate the surface area of this cone. Again, now with the cone, we can still talk lateral surface area, which is just going to be the sides, not the bottom of the cone. There is no top of the cone, of course, right? It's just a point. So just all this side area would be the lateral surface area, and then we'd have the bottom of the cone, which would be just a circle down there. Okay, so lateral surface area is defined as pi times the radius times s, and s is what we're calling this slant height. Okay, so we need to know the length of that side. Okay, so lateral surface area is just pi times radius times the length of that side, the slant height, and of course the area of the bottom is just a circle, so it's pi times radius squared. Okay, so to find the total area, we're going to need to piece those two things together, so let's do that. Example 11 says what? Find the lateral surface and total surface area of a cone that has a diameter of 8 centimeters. So let me draw my little cone here. I've got a diameter of 8 centimeters. A height of 6 centimeters. And a slant height of 7 centimeters. Round to the nearest hundredths, okay? Well, lateral surface area, as we just talked about it, is pi times the radius times the slant height. Now, what's the radius? Well, we're given diameter is 8 centimeters. Radius is just half of that, okay? So it's just as easy to figure out the radius and go from there. So pi times radius times the slant height, so we're going to have pi times 4 centimeters times 7 centimeters. Okay, so if I do that, what are we going to get here? We're going to get pi times 4 times 7 equals. And we were asked to round to the nearest, what were we asked to round to? Hundredths. So I got, when I did this, 87.96459 square centimeters, but if we round to the nearest hundred, that'll be where that 6 is, it'll be 87.96 square centimeters. Okay? Lateral surface area. What about the total? Lateral's fine and dandy, but what about the total? Well, the total equals the lateral surface area plus the area of the base. Okay, that's all it is. So what's it going to be? It's going to be the lateral surface area plus this pi times radius squared, because the base is a circle. So let's figure out what pi times radius squared is, or we can just write it here. We know it's 87.96 square centimeters plus pi times 4 centimeters squared. So let's figure what that is. 87.96 square centimeters plus, we're going to take pi times 4 again, so pi times 16 in other words. Pi times 16 is going to be 50. I'm going to round it to the nearest hundredths. It'll be 0.27 when I round it to the nearest hundredths. Okay, so finally, TSA equals total surface area. I'm going to add those two things together. And what am I going to get here? I'm going to get 50.27 plus 87.96. I'm going to get 138.23 square centimeters. Okay? And there we go. Alright. I hope that makes sense. A lateral surface area is just the area of the sides, and then we need to add, in this case, just the bottom base, because there is no top base. If it were a box or something else, or a cylinder, we would have to add twice that base, because there's a top and a bottom, and in the case of a cone, there's not. Alright, that's really it as far as new material goes. I'll go ahead and get this video posted and let everybody know. I'll let everybody know the exam situation. There'll be a practice exam number 3 and a real exam number 3 in my math lab, and then there'll be a practice final and a real final in there as well. Okay, of course, email me with any questions as usual, and I will get this posted. Thank you.